A light emitting diode circuit. Figure 3.8 shows a battery, a resistor, and a light emitting diode, LED. The LED is one of a family of semiconductor devices which includes ordinary diodes and transistors. They are discussed in the intermediate course. There are two features about an LED which we must consider. The first is that they are sensitive to polarity. They must be connected the right way round. The other is that the diodes are destroyed by high currents. At intermediate level, you will learn that we need to limit the current using a series resistor. Figure 3.8. A battery light emitting diode, LED, and a resistor to limit the current. So there's the LED, there's the resistor, and the battery. The circuit shows a 3 volt battery, a current limiting resistor, and an LED. The LED is specific to run at 1.8 volts and 20 milliamps. That is a 0.02 amp. With 1.8 volt across the LED, the voltage across the resistor is 3 volts. 1.8 volts equals 1.2 volts. Remember, the voltage across the two devices must add up to the battery voltage. We can now use Ohm's law to calculate the resistance of the resistor. The formula we want is R equals voltage divided by current. I is for current. Inserting the numbers V is 1.2 volts and I is 0.2 amps. So resistance equals volts divided by current equals 1.2 or 0.02 equals 120 divided by 2 equals 60 ohms. Practice this so you will be able to do it in the exam. Having a value such as 0.2 amp in the denominator, the bottom of the formula can be awkward to calculate. Here we have simply multiplied the top and bottom, the numerator and the denominator by 100, making the calculation easy. A 60 ohm resistor will set the correct current for the LED. Not all LEDs require the same voltages and currents. The voltage in particular depends on the color of the light the LED is designed to produce.